This demonstrates the peak capability of the modern hybrid pipeline. A rigid circuit board seamlessly transitions into a robotic arm encased in fluid, liquid glass dynamics. The traditional workflow of exporting massive, static image sequences from a 3D application into a compositor is now obsolete. Instead, the 2026 standard leverages direct engine integration. After Effects now extracts raw mathematical data, such as virtual cameras, exact lighting coordinates, and precise object buffers, straight from the engine in real time. This interoperability relies on OpenPBR, a unified standard ensuring that parametric materials react to light and environment variables identically across both software platforms. However, running two distinct render engines simultaneously exposes serious hardware vulnerabilities. Specifically, it pushes the GPU's video RAM to its absolute breaking point. It also introduces mechanical precision errors. When data crosses between applications, subframe interpolation differences cause keyframe drift, forcing 3D objects to slide out of alignment with 2D elements. Furthermore, if the linear color spaces of both applications are not perfectly synchronized, the math behind physically based lighting and physical shadows will fail. High-end 2026 compositing orchestrates a unified algorithmic ecosystem where data flows bidirectionally. This split-screen layout illustrates how a modern pipeline deliberately divides the 3D computational load between two distinct geometry engines. Cinema 4D Lite is strictly reserved for generating complex topological tasks that require heavy calculations. It handles spline-based generators like sweep and subdivision surface, allowing artists to build detailed procedural models that update non-destructively. Cinema 4D Lite also processes Espresso nodes. This visual programming language drives mechanical animations using raw mathematics, bypassing the need for manual keyframing. After Effects 26.0 manages the secondary background assets natively. You build basic cubes, spheres, and planes directly in the compositor using parametric meshes. These native primitives are GPU accelerated. They render almost instantly. Avoiding the heavy CPU overhead required on Cineware calculates a full Cinema 4D scene. Here, Threadripper CPU cores process Cineware data, while GPU VRAM spikes sharply to render native 3D elements. Isolating the VRAM metric shows capacity hitting the 32 GB threshold required by NVIDIA Blackwell architecture. Two simultaneous tasks consume this 32 GB of VRAM, calculating the advanced 3D viewport and decompressing high-resolution Substance 3D materials in real time. The lossless compressed playback feature also relies heavily on this massive memory pool to double the capacity of the active RAM cache. Routing every geometric object through the CineRender engine will throttle and crash the system. Offloading primitive geometry to the native After Effects renderer is a mathematical necessity for maintaining playback stability. Looking at the surface level, this generated macro shot shows a smooth metallic sphere rapidly extruding microscopic threads to create a procedural plush core fabric aesthetic. The Substance 3D connector replaces the process of baking static texture maps by generating parametric.sbsar files at runtime via the GPU. This allows you to adjust specific roughness and metallic values directly in the After Effects Properties panel without opening the 3D host software. To attach 2D graphics, the Cineware extract function pulls the exact 3D null and camera data from Cinema 4D directly into the After Effects timeline. Unfortunately, this extraction process introduces keyframe drift. A 2D graphic perfectly parented to a 3D null on frame 1 will slowly slide out of alignment as playback continues. Cinema 4D calculates animation on discrete whole frames, the top dots. After Effects calculates on continuous time, the bottom curve. Over time, they diverge. To fix this, the continuous curve must mathematically snap to the exact coordinates of the discrete frame dots. The mechanical solution is camera morph baking. Prior to saving the Cinema 4D file, you generate an absolute keyframe for every frame, removing any need for After Effects to calculate interpolation. It also requires matching the subframe frame rate, like 23.976, exactly in both the project settings and the composition settings. Data extraction requires strict mathematical synchronization. Visual approximation will always fail. With the geometry and tracking locked, the After Effects layer stack functions similarly to a node-based compositor. Object buffers generated in Cinema 4D Lite act as isolated alpha channels for specific pieces of the 3D geometry. You stack isolated rendering passes, diffuse color, specular highlights, and ambient occlusion to rebuild the image dynamically. This workflow creates a color space paradox. If you composite linear light data while the project remains in standard sRGB, the result renders washed out and mathematically incorrect. This flowchart maps the linear light pipeline. First, the Cinema 4D light render space is locked to ACES-CG for accurate physical light falloff. In After Effects, the color engine uses Open Color I/O with a strict display transform to ensure accurate monitor output. Matching these profiles is mandatory because the parametric roughness values in substance materials require linear light to calculate physical reactions to After Effects environment lights. Physically based rendering is a color-dependent equation. Without a unified linear pipeline, algorithmic materials calculate inaccurate physical reflections. This infographic quantifies the final result. By eliminating the manual render export cycle and offloading primitives to the native engine, this optimized pipeline reduces total production time by 25%. Sustaining this efficiency requires precise hardware architecture, specifically allocating the After Effects disk cache to a dedicated Generation 5 NVMe drive. Separating this cache drive from your active project file drive eliminates input-output data bottlenecks during heavy preview rendering. Economically, maximizing the built-in Cinema 4D light engine alongside free Substance 3D community assets removes the overhead of third-party software licensing for mid-tier studios. Mastering algorithmic data extraction, smart hardware allocation, and open color I/O management is the strict prerequisite for operating in the 2026 motion design landscape.